good afternoon to all students. So, we are continuing our same chapter, chapter 2. So, yesterday what we have studied? We have studied some of the derivations of equations of motion. So, today we are discussing about the inertia. Our next topic we call as the inertia. So, yesterday also we have discussed somewhat about the inertia. So, what I said about the inertia yesterday, I think you remember that one. That is what inertia means. What inertia? It is a property of an object which tends them to be in the state of rest or motions or in a particular directions. Okay? It is the property of an object, that may be the bus, vehicle or whatever object, that tends them, that keep them in the state of rest or motions or in a particular direction where they are moving on. For example, a bus is moving this side. If anything or any external force is not applied, then it will continuously move towards the same direction. So, it is the property of that bus to move in the particular direction. So, that is called as the inertia. So, it is again I will repeat that one. Inertia is what? It is the property of an object by the virtue of which it tends in the state of rest or motion or in a particular direction. If any unbalanced force applied on it. So, you may find a definitions in a book that any external force is applied on it. Okay. But if we have already studied about the balance and unbalanced force. Yes, you are clear about that one, that is the balance and unbalanced force. So, if the balanced force is applied on it, does it change its positions? Yes? No, it cannot be. For example, these markers are been there. So, if I will press like this, it changes its position? No, I have to press more, then only it change. Therefore, the external force which is applied on it, that should be unbalanced force. Okay? That should be unbalanced force. So, what is inertia? That is the property of an object by a virtue of which it is in the state of rest or motions or move in a particular directions if any unbalanced external force applied on it. Unbalanced external force applied on it. So, actually we are studying the three types of inertia. Okay. What are the three types of inertia? Inertia of rest, inertia of motion and inertia of directions. Okay. What are they? The first one is inertia of rest. Good. Then next one is inertia of motion and the next one is inertia of what? That is directions. Very good. So, there are three types of inertia, that is the inertia of rest, inertia of motion and inertia of direction. Let us take a talk about the inertia of rest. So, what is inertia of rest? That is the tendency or the property of the body. It is the property of the body that tends them to be in the state of rest, that tends them to be in the state of rest, okay, in the state of rest until and unless, what I said, until and unless an unbalanced external force applied on it, until and unless unbalanced external force applied on it. It will not apply its own force. The different parts, external force is to be applied to move this marker, isn't it? This marker is been moved if I press like this, that is the unbalanced external force. I applied on it, then only it moves, means it is in the state of rest. And on the, what is the property of the marker here? It is the property that it will remain in the state of rest, and if I will apply unbalanced force on it, it will move. That is called as the inertia of rest. There are lots of example we have, and some of the reasoning questions are been given in your exam also. For example, we are sitting in a bus. We are sitting in a bus. Suddenly what happened? A bus start from rest. Okay? We are sitting on bus, then suddenly what happened? The bus start from rest and it moves. What happened? We will jerk backside. Yes or not? Yes, we will jerk backside. Why we are been jerking backside? Why? Because the bus will be in motion now, and our leg which is in contact with the bus will also in motion. Then half of the part which are untouched to the bus, that will try to tends to be in the state of rest. Therefore, we will jerk backside. That is the example of what? That is the example of inertia of rest. Yes, good. That is the example of inertia of rest. So, when it will ask in your exam, you can write that it is due to the inertia of rest, because the parts, lower part which is in touch with the bus, that will come into motions, and the upper part which will not tends to be in rest, that is why we will move backwards. Okay. The another example is been there, inertia of rest. Lots of the time it is been asked in class 9, in reasoning questions, why the dust particle, why the dust particles is been come out when we beat the carpet. Okay. When we beat the carpet, we by hanging, you may try at home also. That means by hanging the carpet, we beat like this, and the dust particle will be fall down. Why? What is the reason? It is due to inertia of rest of what? Carpet or dust particle. Good, very good. That is the inertia of the rest of dust particle. Particle try to be in rest, whereas the carpet will be motion. Due to unbalanced force, it will fall down. That is the another example of the means inertia of rest. Let us take the another example again. The another example, now it is a period of lychee and mango, isn't it? So, you may shake the tree of the mango and the lychee, then what happen? It will fall down. Why it will fall down? Why it will fall down? Why? Because of inertia of rest of tree or the fruits, that is of the fruits. The fruits try to be in the state of rest, whereas the branch will shake. It means it will come into motion, and due to unbalanced force, it will fall down. So, I think by giving these three examples, it is clear to you that what is inertia of rest. Once again, I will say it is the property of the object to be in the state of rest until and unless external force, unbalanced external force applied on it. Okay. Now, comes to the next one is the inertia of motion. So, what is inertia of motion then? It is just similar. In rest, what? The body, the property of the body is what? In rest, inertia of rest, the property of the body is what? It tends to be in the state of rest. And what will be in the inertia of motion then? In inertia of motion, then what happen? The body will tends to be in the state of motion, in the state of motion. Okay? The body try to be in the state of motion. So, what is inertia of motion? It is the property of an object that tends them to be in the state of motion until and unless unbalanced force act on it. Until and unless unbalanced force act on it. It's good. So, it may be clear to you about the definitions of inertia of motion. Let us take some of the examples so that we may clear our idea about what is inertia of motion. Let us take some of the example. So, in inertia of rest, what example we have? We have example of bus start from rest, isn't it? Now, let us take the another example of the same bus which is been moving. So, we are sitting like this in a relaxed means actions, relaxedly we are sitting in a bus seat. Then what happened? Suddenly, all of sudden, what happened? The means the driver apply a brake. Okay, driver apply a brake. Then what happened to us? What happened to us? Immediately, what happened? Suddenly, we will fall front side. We will jerk on front side. Why it's happened? Let us take why it's happened. When a brake is applied by a driver, then we will jerk in front. Why? In bike also, bicycle also, vehicle, car also, bus also, whatever we are moving, when we suddenly stop that one, we will jerk in front. Why? That is because inertia of motion. How? The question is right, how it is due to inertia of motion. Now, again take the example, the bus when it moves, it jerks, then what happen? Our leg is been touched with the bus and our body is not in touch with the bus. That parts will on the seat. Okay? We are relaxedly sitting and a down part is in touch with the body of the bus. Then what happen? When a brake is applied, the lower part, the leg part will come into rest, but which are hanging on above the means wrist. Then it will what? It will move forward because it wants to be in the state of motion. Okay, it wants to be in the state of motion and it wants the leg will be come into rest. Therefore, due to unbalanced force, we fall in front. That is, our body is in motion and it try what? It try to be in motion. That's why it's move forward. Okay, that types of questions will be asked in your exam reasoning. Then let's take another example. Another example, some of in the young age, lots of the peoples have to travel in local bus. Have you traveled in local bus? Yes, most of you have been traveled in local bus or bike. Okay, so sometime what happened? The bus suddenly run and it will not stop at our means bus stations. Then by running bus we get down and we move somewhat forward. Okay, why we are moving forward? From while means coming down from the moving bus. What is the reason? What happened? Along with the bus, our body is in motion. Okay, along with the bus, our body is in motion. But when we come in contact, our leg is come in contact with a ground, then what happen? Lower part will come into rest and the upper part tends to be in motion. Therefore, we may fall down. Okay, we may fall down. Therefore, we have to move somewhat forward so that we will balance the motions. Okay, this is the another example of motion. We have to move some distance when we jump suddenly, speeding bus suddenly, because our body will be in motions and if we will jump to the ground, then the means our body come into rest and all of sudden it will unbalance our body and we may fall down. Therefore, we have to move some apart so that we will balance the body. Then next comes to the, so I think it is clear about the inertia of motions to you. Okay. Then comes to the next one, inertia of directions. So I think it is now clear what is directions means. So it is the property of the body. It is the property of the body that tends them to be in the state of a particular directions, in the states of particular direction until and unless some external unbalanced external force applied on it. You can see while riding your bicycle also. While riding bicycle, you may find that one also. Means if sudden things, stone or any things come in front of your tire, then what happen? Your bicycle will be jerk or move here and there. Or if you are straightly moving, you can raise your hand and without touching the handle, you can drive your bicycle in a straight way. Why? Because there is no any external force that distract you from the directions. Therefore, what we can say that inertia of directions is the property of the body by a virtue of which it is in the state of a particular directions until and unless unbalanced external force applied on it. Okay. Let us take also the same example, some of the example. Okay. Some of the example. Now, while traveling in bus or the vehicles or any motorcycle or any other way, when we take a U-turn, okay, when we take a U-turn, then what happen to our body? We are moving straightly and we take a U-turn, then what happen? If we take a turn like this, then what happen? Our body will move like this. Yes, the straight body will move like this. Why it's happen? Question is why it's happen? Because it is due to inertia of directions. Okay. Why? Because it is due to inertia of direction. When it moves in a straight line, our body is in the direction straight line. But when it takes a turn, then what happen? Our body will try to be in a straight position, but what happen? Due to the change in means direction, our body will also what? Unbalanced. Therefore, it will all of a sudden what happen? It will move here and there. Now comes to the next one, next example. While driving a bicycle or the means that is the vehicles during the rainy seasons, the muds and the water. Suppose you are driving a bicycle like this, then what happen? The water which is present in the ground will spread here like this. That is been seen, and with the why it is been happen, why it's happened that one, why? When the vehicle pass, what happened? The water spread backward, upward. Why? Tangible form, for like this, tangent. Okay. Why it's happened? Because of the inertia of directions. Okay. The rolling this one, the tire is been rolling like this, it going. So, where the tire moves? This way, not this way. It is not moving this way, it is moving like this. So, what happened to the water? Water will also move towards the upward direction like this. So, it tends to be in the same direction. Therefore, the muds and the water that is been straight means towards the tangential form, to the tangent, okay, tangent way. So, I think you are clear about the inertia of rest, inertia of motion and inertia of directions. Let us come to the next topic, that is momentum. So, do you heard the word momentum? It is not in class 8, therefore, I think you have not heard that one. So, what is momentum then? Momentum of a body. So, we are only reading in this chapter about the linear momentum, not in circular momentum, it is linear momentum. Means momentum in a straight line, okay? In a straight line. So, what is momentum then? What we say? It is the total motions of the object. It is the total motion of an object. Okay, it is the total motions of an object. So, how the total motions is been calculated? So, it is denoted by P, momentum is denoted by P, and it is P equals to m into v, that is the mass into velocity. Mass of an object into velocity of an object. Okay. Mass of an object into P is denoted momentum. Momentum P equals to mass of an object into velocity of an object, that is what? M into V. So, what is the unit of M? SI units of M? Yes, good. That is what? Kg. And what is the units of velocity? That is, yes, that is meter per second. So, what will be the units of momentum now? Kg meter per second. Okay. Kg meter per second is the what? Is the momentum, units of momentum. Which unit? SI units of momentum. So, are you clear this one? Yes. Now comes to the next topic, law of motion. Of motion. Okay. Law of motion. So, what are the law of motions? It was given by Sir Isaac Newton. We have discussed before also. There are three laws of motion. What are these? First law of motion. Then next, second law of motion, and third okay. These are the three laws of motion which we are going to study. Now, what is Newton's first law of motion? It is also known as law of inertia. Why it is also known as law of inertia? Because the first law of motion states that an object will be in the state of state of rest or motion or in a particular direction until and unless an unbalanced external force applied on it. Okay. So, it states that the object will be in the state of rest or motion or in a particular directions until and unless external force applied on it. So, it is just similar to the definitions of inertia, isn't it? Therefore, it is also called as the law of inertia. So, what are the example of first law of motion? That is the example of inertia of rest, inertia of motion, inertia of directions. Okay? I have already give you the example. The law of inertia, during the law of inertia, inertia of rest. What are the example? Shaking of tree, falling of fruits. Then the next one is the jerk of body forward when a bus suddenly stop. Then the body jerk backside when bus suddenly move. These are the some of the example of what? The first law of motion. So, without external force applied, the body will be in the state of rest or motion until in the state of rest or motion. So, the next one is the why there are some of the reasoning questions is also there. Why the athlete jumps before taking a long jump? Why? So that the body, it will make their body to be in motion, so that they can take a long means jump. Then the next one, when we say some of the soldier moving means running in a full speed, and if we tell them to stop immediately, they cannot, they will fall down. Why? Because the body will be in motion, and if they want to be in the rest, then what happen? Due to unbalanced force, they will fall down. It is due to the first law of motion or law of inertia. Okay? I think you are clear to that. Now comes to the next, second law of motion. Second law of motions, what it say? Second law of motion states that the acceleration produced by an object is directly proportional to the force applied on it, and inversely proportional to the mass of an object. Numerically, we can say like that: A is directly proportional to the force applied, acceleration is directly proportional to the force applied. A denote acceleration and F denote force. And second one, what is said? Acceleration is directly proportional to the force applied on it, and inversely, A is inversely proportional to the mass of an object. Inversely means 1 upon m. So, by combining this equation, 1 and 2, we have what? A is directly or inversely proportional to 1 upon m. Oh, sorry, f upon m. And can we write like this? Or f is directly proportional to m into a? Yes, we can write. Therefore, I rub this one. So, f is directly proportional to the product of mass and accelerations of the body. Therefore, f equals to k into m into a, okay, where k is a constant value. K is a constant value. Therefore, f equals to m into a. So, if we want to prove this one, let us take the force, okay, let the force applied on an object, in an object, is 1 Newton and 1 of 1 kg mass having an acceleration of 1 meter per second square. Then what happened? F equals to k into m into a. I write this one, m into a. Then 1 equals to k into 1 into 1. That means k equals to 1. Therefore, f equals to m into a. So, we have derived that force equal to mass into acceleration. So, what will be the 1 Newton force? 1 unit force is the product of 1 unit mass of an body in and 1 meter per second square acceleration. So, this is the Newton's second law of motions, and the third law of motions we will continue tomorrow. So, till here we will finish our topic till here for today, and tomorrow we will continue. So, thankful to all of you for your attentive in this class. Thank you very much.